Welcome to EDU World Space.
In this problem, we have three monochromatic light waves. The first one, the wave equation of first one is E cosine omega t. The second one is E cosine omega t plus phi, and the third one is E cosine omega t minus phi. So here for part A, we get the total wave equation of the interference pattern. So here y just equal to y1 plus y2 plus y3, and this is equal to e cosine omega t plus e cosine omega t plus phi plus e cosine omega t minus phi. So here y just equal to e cosine omega t plus e cosine omega t cosine phi minus e sine omega t sine phi. This is for the second term here. For the third term, we have plus e cosine omega t cosine phi plus e sine omega t sine phi. So now this term cancels with this term, and here we would have y to be equal to e times 1 plus 2 cosine of phi multiplied by cosine of omega t. So here the amplitude of this wave is just e times 1 plus 2 cosine of phi. This is for part A. Now for part B, we have the intensity is just equal to the magnitude of the amplitude squared. So this is equal to e squared times 1 plus 2 cosine of phi squared. But now for the maximum interference pattern, we must have here cosine of phi to be equal to 1, such that this bracket is just equal to 3 squared, which is equal to 9 for the maximum interference pattern. So here I0, which is corresponding to the intensity of the maximum interference pattern, would be equal to 3 squared, which is 9 times e squared. So this is 9 e squared. So now e squared is just equal to the maximum intensity divided by 9. So now for the intensity at some point P, IP is just equal to I0 divided by 9 multiplied by 1 plus 2 cosine of phi squared. This is for part B. Now for part C, for the lesser maximum, we must have phi here, or this term, to be equal to 0 or to be equal to -1. In case if it's 0, we would have here IP is equal to I0 over 9, and in case cosine of phi is equal to -1, so here we would have -1 squared, which is 1 times I0 over 9. This is related to the lesser maxima. So here phi must be equal to 0, which implies that, sorry, here cosine of phi must be equal to 0. So here phi must be equal to m plus half times pi, or cosine of phi is just equal to -1, and here phi would be equal to 2m plus 1 times pi, where here m is just an integer. This is for part C. Now for part D, the intensity for the lesser maxima, IP would just be equal to I0, which is the maximum intensity, divided by 9. This is for part D. Now for part E. For part E, or to get the dark fringe, we must have cosine of phi to be equal to -1/2 for this here IP. If cosine of phi is equal to -1/2, this bracket is just equal to zeros, and now the intensity is just equal to 0, which is corresponding to the dark fringes. So here cosine of phi must be equal to -1/2. So now phi is just equal to 5 over 6 times pi, or phi is equal to 4 over 3 times pi. This is for part E. Now for part F. If the monochromatic light would have the wavelength lambda is equal to 650 nanometers, or 650 times 10 power negative 9 meters, and the distance r from the slits to the screen is just equal to 1 meter, and the distance between the slits, d, is just equal to 0.2 millimeters, or 0.2 times 10 power negative 3 meters. So here the distance to the lesser maxima y is just equal to delta x, which is the path difference, times r divided by d, but we know that delta x, the path difference, times 2 pi over lambda, just equal to the phase difference, delta phi, and this is equal to m plus half times pi for the lesser maxima. So now y is just equal to lambda r divided by 2d multiplied by m plus half, where m again is just an integer. So now here we let m is just equal to 1. So now y is just equal to lambda, which is 650 times 10 power negative 9 times r, which is 1, divided by 2 times d, which is 0.2 times 10 power negative 3, times m plus half, which is 3 halves. And now y is just equal to 2.44 times 10 power negative 3 meters, or 2.44 millimeters. This is for part F. Now for part G, we have here y is just equal to r lambda m divided by 2d, and again fm is just equal to 1. So now y, and by the way here y is the distance from the central maxima to the absolute maximum. So now y is just equal to r, which is 1, times lambda, which is 650 times 10 power negative 9, times m, which is again 1, divided by 2d, which is 2 times 0.2 times 10 power negative 3, and this is equal to 1.625 times 10 power negative 3 meters.